Good evening, my respected teacher. I am Sayan Baral from third year EC department. My roll number is 34900323047. Today my topic is operation of MOSFET. Let's start by understanding why MOSFETs are so important. Almost every electronic device we use today, mobiles, laptops, chargers, processors, depends on MOSFETs. They act like smart switches that can turn circuits on and off very efficiently. What exactly is a MOSFET? A MOSFET stands for metal oxide semiconductor field effect transistor. It is a very it is a voltage controlled device, meaning we control current using voltage, not current. It has three terminals: gate, drain, and source. The most interesting part is the gate. The gate is not directly connected to the rest of the device. Instead, it is separated by a very thin oxide layer. Because of this insulation, almost no current enters the gate, which gives MOSFETs their high efficiency. So basically, we apply a voltage at the gate, and the device decides whether current should flow or not. Then, how is a MOSFET built? Inside the MOSFET, we have a semiconductor substrate, um, two heavily doped region called source and drain, an insulated gate on top. There is no wire between the gate and the channel. The gate controls the channel using an electric field, which is why it is called a field effect transistor. Then different types of MOSFETs. MOSFETs mainly work in two modes. First one is enhancement mode, and then the second one is depletion mode. These enhanced mode is basically these are normally off devices, turns on only when gate voltage crosses a certain value called threshold voltage. And then depletion mode, it is normally on for this is normally for the on devices, needs reverse gate voltage to turn off. In practical digital circuits, we mostly use enhancement mode MOSFETs, especially NMOS and PMOS. Then how does an enhancement NMOS actually work? This is the heart of the topic. When no voltage is applied to the gate, no channel exists, so current cannot flow. This is called the cut-off state. Now, when we apply a positive voltage to the gate, something interesting happens. The electric field attracts electrons towards the region under the gate. Gradually, these electrons form a thin conducting channel between the source and drain. Once this channel is formed, current starts flowing from drain to source. So simply by changing the gate voltage, we control the current flow. That's the beauty of MOSFET. Then operating regions of MOSFET. Depending on voltage, the MOSFET behaves differently. Cutoff region, linear region, and saturation region. In cutoff region, gate voltage is too low and MOSFET is off. In linear region, the channel is formed. MOSFET behaves like a variable resistor and useful in analog circuit. And then at last, saturation region. Here channel gets pinched near the drain and the channel becomes almost constant, used in amplifiers and current sources. Then channel formation and pinch off. As drain voltage increases, the channel near the drain becomes narrower. At a certain point, it pinches off. Even if we increases drain voltage further, the current doesn't increases much. This condition is called saturation, and it is very useful in circuit design. Here it is, the slide. Then, why are MOSFET parameters important? I mean, key parameters affecting operation, the slide name. Here some key parameters control MOSFET behavior. Threshold voltage, it decides when it turns on. Channel length and width, it decides how much current flows. And then oxide thickness affects speed and reliability. Engineers carefully design this to get better performances. Then MOSFET as a switch. In digital electronics, MOSFET works like electronic switches. It gets low when the switch is off and it gets high when the switch is on. They switch very fast, waste very little power, and are extremely reliable. Then the summary or the final thoughts. To sum up, MOSFETs are the foundation of modern electronics. They are efficient, fast, and scalable. Understanding their operation helps us understand how real circuits works. Thank you.